Good evening, everyone. Today we are presenting Privacy Book, a Privacy by Design Home Services and Contact Tracing System developed for secure software engineering. My name is Harsh, and I will be starting with the introduction, the problem, our solution address, and then giving a quick overview of our system. Next slide, we have the problem balancing utility and the privacy. The post-pandemic home services still need to operate, but sharing full addresses to the early exposures users to the privacy and the safety risk. At the same time, contact tracing is important, but many traditional system relies on centralized tracking that can feel intrusive. So the challenge is finding a balance. Service providers need enough location information to do their job, but the user should maintain strong control over their personal data, and exposure alerts should work without turning into surveillance. Our project focus on solving all three of these major concerns simultaneously. Next slide, we have the system overview and the technical stack. To address this, we build a privacy first architecture using Next.js on the front end and the Firebase authentication plus the Firestone on the back end. Sensitive information like the full addresses and the encounter tokens is protected by AES 256 CBC's encryption. The workflow is simple. User creates a booking with the hidden address. Providers only see full details after accepting the job, and both sides generate encrypted encounter tokens for the privacy preserving contact tracing. Exposure checks happens locally on the user devices, so the server never learns movement history. This gives us the secure minimum data system that still supports real home services workflow. Next slide will be covered by Hanin. Over to you, Hanin.
For my part of the presentation, I'll be walking through the core privacy and security design choices behind our system and how we structure the data model to enforce strong protection of user information. Core security requirements. Our system follows a strict privacy first approach. The first principle is minimal user address sharing. We only reveal a user's exact address once a provider has committed to the job. Before that, providers only see the suburb. This prevents unnecessary exposure of sensitive location data. Next, we use encrypted encounter tokens. Every encounter is anonymized and stored in encrypted from using AES 256. So even if someone gains access to the database, they cannot reconstruct social interaction or identities. We also rely on local device-based risk check. Exposure matching happens fully on the user's device, not on the server. This gives us true zero-knowledge privacy since the server never learns user histories. Role-based access control. It further strengthens this. Users and providers have different permissions, and providers cannot view private details unless the system explicitly authorizes them for a specific booking. Finally, we store time in course availability windows like morning or afternoon instead of exact timestamps. This prevents behavioral profiling or pattern recognition from user activity. Next slide. To support these privacy requirements at the technical level, we designed the data model using a strict separation of concerns. Public information such as suburb, service type, and booking status goes into the booking document. Private information like the full address and phone number is placed into a private detail subcollection under the booking. This separation makes accidental data exposure far less likely because broad queries never return sensitive fields. It also allows us to apply very precise firestore rules only on the private node. For contact tracing, we use two additional structures. Encounter documents store encrypted encounter tokens linked to the booking. Exposure tokens store decrypted tokens from positive cases for the user's device to match locally. Overall, this modular model keeps sensitive data isolated and enforces privacy through database design itself, not just the application code. Finally, this slide shows how we implement granular address privacy using the need-to-know principle. Before a job is accepted, the provider sees only a blurred or hidden addresses. They can get enough information to know the suburb, but not the exact location. This protects the customer from providers browsing through addresses without committing. Once a job is accepted, Firestore permissions are automatically updated. Only the assigned provider's UID gains access to the private detail subcollection. At this point, the full address is revealed securely. This dynamic permission update ensures that the address is only ever visible to the right provider at the right time and is completely hidden from everyone else. So overall, our design shows that it's possible to deliver functional home services and privacy preserving contact tracing without exposing sensitive user data. By combining encryption, local computation, role-based access, and a carefully structured data model, we create a system that is secure by design and transparent for users and providers.
Moving on to the core of our privacy architecture, let's discuss contact tracing. Standard apps often fail because they centralize data, creating a massive honeypot of users' locations. We took a different approach instead by using the DP3T protocol, which is the gold standard for privacy. Our architecture effectively turns the server into a blind Dropbox. Here's a technical workflow. That is, first is token generation. So the moment a booking is confirmed, our API generates a random UUID, which is the unique user ID. This is a encounter token. It has no mathematical link to the user's identity. It's just a random string. Then it goes to the server-side encryption. So this is a critical step before the token is ever written to our database. We encrypt it using an AE6256 CBC with a secure server-side key. This means our database administrators and even potential hackers only ever see encrypted gibberish. Secure distribution. The server stores the encrypted version. The unencrypted token is sent back to the user and provider exactly one time via the API response. Their device then saves this plain token into the browser's local storage. Bottom line is we have separated mathematically the identity from the interaction. If our database is compromised tomorrow, the attacker gets nothing but uses encrypted strings. They cannot reconstruct it who met whom. Now on to the next slide. The client-side exposure matching or the zero knowledge check. Trace the flow from reporting matching to the head. So if the server has only encrypted data, how do we want people? We utilize client-side exposure matching. In cryptography, this is often called a zero-knowledge check because the server facilitates the check without knowing the result. The lifecycle of an alert is in such a way. Reporting. Let's say user Alice tests positive. She clicks report on her dashboard. This uploads her list of encrypted tokens to the server. Note that she isn't uploading Bob's name, just the anonymous token from her history. Decryption and broadcasting. The server uses its private key to decrypt the specific tokens and adds them to the public exposure list. This list effectively says if you have any of these random numbers, you might be at risk. Then local matching. This is where the magic happens. Every other user in your device, including Bob's iPad, periodically downloads the list. It compares the list against its own local storage. So why does it matter? It matters because if Bob finds a match, his screen turns red. But crucially, the device never tells the server never receives a query like, did Bob meet Alice? The alert happens entirely on Bob's phone, preserving his privacy completely. So now moving on to the next slide. Securing our database with 5-store rules. So the point specifically allow read and write to the database using the 5-store rules. So finally, we need to protect the most sensitive asserts, the user's home address. In a traditional app, you might hide this in the front-end code, but the savvy attackers can bypass the UI and query the database directly. To stop this, we implemented database-level enforcement using 5-store security rules. We structured our data so that sensitive data details live like in specific subcollections called private detail. If you look at the code on the screen that allows read statement, our gatekeeper executes a strategic logic check for every single request. It fetches the parent booking document. It compares the provider on the booking assist of the UID to the person asking for the data. If they don't match the database, it rejects the request instantly with permission denied. This prevents enumeration attack. A malicious attacker cannot simply write a script to guess the booking IDs like booking 101, 102. Okay, even though the guesser might guess the booking ID some way, because of the rules, he cannot access the data. So this ensures we strictly follow the principle of least privilege. That is, the user only sees exactly what they need to see and nothing more. Thank you.
Hi, I'm Rahul. I'm going to talk about UX transparency and privacy focused design philosophy in this slide. Our design philosophy ensures that privacy is clearly visible and built directly into their user experience, rather than hidden inside long and complex terms of service. The interface separates public info from private details, allowing users to immediately understand what information will be shared and at what stage. This transparency is reinforced through role-based dashboards, where providers receive a layout designed for job discovery, while users are shown a dashboard that focuses on their safety status and the management of their bookings. Through these choices, the system makes privacy understandable and always present during user interaction. And the next slide is um privacy preserving contact tracing prototype walkthrough. The prototype illustrates how privacy preserving contact tracing can work in a real service workflow. It begins when Alice logs in and submits cleaning request. Bob is able to view the job, but the only but he only sees the general suburb, ensuring Alice's exact address stays hidden at this stage. Once Bob accepts the job, the system grants him access to full access, and both Alice's and Bob's devices automatically store an encrypted encounter token. If Alice later reports a positive test, she uploads her encrypted encounter tokens to the system. When Bob opens his dashboard, his status changes to red, which is exposed, informing him of a potential exposure while still maintaining Alice's anonymity throughout the process. And the next slide here is conclusion and future directions. In conclusions, our prototype demonstrates meaningful advancements in privacy preserving contact tracing. We successfully created a system that maintains confidentiality and enforces strong address privacy using cryptographic protection and ensure database rules. Looking ahead, we plan to strengthen the system um, further through uh, further through a few improvements will enhance long-term security and maintain strong privacy guarantees within the platform. Thank you.
So here I've opened two tabs. So one will be logging in as a customer and will be providing another one. So I'll be signing up quickly to both of them. We're creating a new account. So as you can see, this is our UI. So this is for a new booking. So I'll just quickly go make a new booking in as a customer. So you can choose a cleaning, like this is a type. Just go in the suburb, main address. We can, so this was in one of our requirements as a course window to not specify the exact timings, so to prevent behavioral at profiling of users. So we can just keep morning, evening, afternoon. So I make a request here. So here we can see the user has created a request. So this is a request. It's still pending because nobody has accepted it yet. So now we go back to our dashboard, and over here as a provider we look for find jobs. So these are all the jobs listed. So I can see this one, the one I just posted right now. So if I start viewing details, I can't see the job. Okay, but when I accept the job, now I can see this was the address we just put in. So this was the new address unlocked. So this is one of the major features of our app. So now I'll just do one thing, like I'll report a positive. So that is positive. So now the encounter tokens are uploaded into the server. So it is now, so you can see it over here. And now if I just refresh my client side, because I had an encounter, the potential exposure comes to the customer side too. So this is in a quick wrap basically what our website does. It's just a quick summary on our main requirements, that is the encounter tokens, the course window to prevent behavioral profiling. The address is not completely shown before the this request is accepted. So thank you for your time. So this was my demo.